Hello, let's talk about the law of flotation. So we have here an object which is floating in a certain kind of fluid. Since this guy is floating, we know that its downward weight is exactly balanced by the upward upthrust exerted by the surrounding fluid. So we write here, the weight of the object is equals to the upthrust exerted by the fluid. The weight of the object is rho Vg. The upthrust is also rho Vg. But you got to be careful which rho and which v you sub in. So the weight of the object is about the object, so the density is the density of the object. As for the volume, is the entire object's weight, right? So the volume here must be the entire volume. Now moving on to the upthrust. Upthrust is numerically equals to the weight of the fluid displaced. So it's about the fluid, so the density has got to be the density of the fluid. As for the volume, we're talking about the weight of the displaced fluid. So it's only this amount of fluid we are talking about. So the volume refers to the displaced volume, which is this part here, the submerged volume. So the G will cancel away, rearrange this thing, and we got this expression here. So what is this telling us? The submerged volume divided by the object's volume is equals to the ratio of the density. So what it's saying is the fraction of the object that's submerged is determined by the density of the object as compared to the density of the fluid. Alright, let's see whether you have grasped this concept here. So I have here many cubes here made of different material. I've listed the density here. We are going to try to float them in water. So water has a density of 1 gram per cm cube. So can you make a sketch like how they are going to float or sink? It's important you try to get your own answers before I go through the answers. Okay, I assume you have made your sketches. So I'm going to go through the answers now. For the ease of discussion, let's assume that all these cubes have a volume of exactly 1 cm cube. So all of them will have different weights. The cork, for example, will have a mass of 0.25 grams, whereas the plasticine will have a mass of 1.9 grams. Let's start with the cork. The cork is definitely going to float, but how high is it going to float? It's going to float with exactly 1/4 of its volume submerged. Because the cork has a mass of 0.25 grams, so to float, it must displace 0.25 grams of water. Get it? So this is 0.25 cm cube of water, which weighs exactly as 1 cm cube of cork. Okay, moving on, wood. Wood is definitely going to float, and it's going to float with 2/3 of its volume submerged, because 1 cm cube of wood has the same weight as 0.67 cm cube of water. Get it? Moving on to ice. Ice has a density of 90% compared to the density of water, so it's going to float with 90% submerged and 10% above the water. There's this saying, the tip of the iceberg, right? So the tip of the iceberg is actually about 10% of the actual volume of the iceberg. Okay, water is going to be a no-brainer, right? Of course, water must be fully submerged. But the interesting thing is this, it can float at any depth, yeah? Don't make the mistake of thinking the water cube must be like just below the water surface. It can be anywhere. Whether you are here or here, you are displacing 1 cm cube of water, which is 1 gram of water. It doesn't matter which depth you are at. Now in practice, what will have a density of 1 gram per cm cube? Well, maybe not a particular material, but maybe the overall effective density. For example, the scuba divers will try to achieve a neutral buoyancy by making their overall density the same as the surrounding water, and they do that by adjusting the weights they wear around their belt and by adjusting the amount of air in their vest. Moving on to plasticine. Plasticine is not going to float, it's going to sink all the way down. Why? Because the plasticine can at most displace 1 cm cube of water. So at most, it can displace 1 gram of water. And the weight of 1 gram of water is definitely less than the weight of 1.9 grams of plasticine. So the plasticine cube cannot be hovering here. It has to sink all the way down, eventually touching the bottom, so that the normal contact force will come in to support the rest of the weight. Same thing for aluminium. It has to sink all the way down, get the help from the normal contact force in order to get supported. At this point, maybe I want to remind everyone that the upthrust is always numerically equals to the weight of the fluid displaced. But whether the upthrust is equals to the weight of the object or not depends on whether the object is floating. So in fact, you can see here, only for these objects here, can you say that the upthrust is equals to the weight of the object? The upthrust is obviously less than the weight of the object for the plasticity, which is why they sink. Alright, that's all. Ta-ta!